will have to do the other wireless technologies. Other than the mobile wireless communication technology, we have other wireless technologies as well, Wi-Fi, Bluetooth, and all of that. I think you have done the report also. Many of you have submitted. Anyway, let's quickly do it, right? And I'll take attendance after some time. Okay, so last week we discussed about GSM network architecture. GSM network architecture can kata kara. In GSM network architecture, we discussed different aspects of GSM services. What is GSM? What are the different three types of GSM services? GSM is a 2G technology, right? So it is the base technology for every wireless generations that are there up till now. GSM infrastructure is the basic wireless mobile communication infrastructure, right? So we did about different types of services and the network infra architecture. So you have to remember that. I mean, if you have referred to the past paper, there is a one single question based on the GSM network architecture, right? So just try to remember this. And then we discussed different parts of the GSM network. Yes. So what are the different tasks done by each part? And these are very important, these databases, right? Home location register, visitor location register, authentication center. So I hope you remember now. So you have to remember the long form of all these databases and what they do, what they store, right? Okay, then we discussed about the security in GSM, then characteristics of GSM standards, data rates, frequencies, and then advantages of GSM over analog systems, Gsm evolution, right? So GSM evolution, this is 2G, this is 2.5G, and then 2.75G and 4G. So 3G. So towards 3G, there is evolution, right? From 2G to 3G, there is a kind of a GSM evolution. So we have to discuss a little bit about Gprs and edge. Okay, Gprs saha edge ගැන කතා කරන්න ඕනේ because those are in between in the GSM evolution. GSM is the basic standard, then it has evolved to Gprs, then edge, right? So now GSM, like I said, it was the most successful second generation cellular technology. It was the most successful cellular technology that was implemented by far. Harith GSM tamai ගොඩක්ම successful cellular technology. But then you know, with the expansion of the number of customers, right, with the expansion of the amount of, I mean, the customer requirements are expanding, the number of subscribers are also increasing. So with the increasing demand, we have to offer higher data rates, and we have to offer high speeds and higher data rates and high quality data transmission, right? So we have to upgrade the network to a much more IP friendly way, right? So then the first system to make an impact on the market was Gprs. So Gprs stands for General Packet Radio System. Remember that Gprs stands for General Packet Radio System. So it enabled higher data rates. So that was the requirement with the basic GSM technology. When the number of customers are increasing, when the service requirement is increasing, we need higher data rate. So GPRS was the solution introduced to offer higher data rates, right? Compared to GSM. Then these are the parameters of GPRS technology, right? Key parameters. The channel bandwidth is 200 kilohertz. Modulation type is GMSK. Data handling is packet data, right? So data packets. Then maximum data rate is 172 kbps. These are the specifications of GPRS technology. GPRS specifications right? Then so let's do a little bit about what is the network infrastructure of GPRS. GPRS network infrastructure. So GSM and GPRS, they interoperate with each other. Interoperate means they work alongside with each other in the same network. Not that now when the GPRS was introduced, there was no necessity to replace the whole GSM network, right? Existing GSM network එක replace කරේ නෑ GPRS introduce කරා කියලා. So with the introduction of GPRS, the GPRS was able to operate alongside with the same GSM network. GSM network එකත් එක්ක parallel operate වෙන්න පුළුවන්. So are compatible. They are compatible with each other. It was a network upgrade itself, right? So it operated alongside with each other by using same base stations. හරිද? එතකොට මේක overall GSM network එක replace කරන්න අවශ්‍යතාවයක් නැහැ. එකම base stations වලින් communicate කරන්න පුළුවන් even in GPRS also. Right? So but the upgrades are necessary. There were slightest changes to the GSM existing network. Existing network එකට යම්කිසි changes introduce කරන්න වුණා, but not the overall network was not completely replaced, right? So network upgrades reflect many of those needed for 3G, and yes, yeah. So it is a pathway. Now GPRS it provided a pathway for the evolution towards 3G. 3G to 3G වලට යන pathway එකක් intermediate step එකක් විදිහට තමයි අපිට GPRS identify කරගන්න පුළුවන්, right? So in this way GPRS became a stepping stone used for migration from 2G to 3G. So with the introduction of a slight changes to the GSM network infrastructure, we could evolve from 2G to 3G, right? So it became a middle step or stepping stone towards the path towards 3G, right? So it is a middle technological upgrade. 2G වල ඉඳන් 3G වලට යනකොට මේ මැද තියෙන technological upgrade එකක් තමයි GPRS කියන්නේ. හරිද? With GPRS providing a move from circuit switch to packet switch. So this is the most important feature introduced in GPRS technology. GPRS වල introduce කරපු ගොඩක් වැදගත්ම feature එක තමයි circuit switching වල ඉඳන් packet switching වලට transfer වෙච්ච එක, right? So it was necessary to upgrade the network architecture to accommodate this. So circuit switch network එකක් packet switch වලට transfer කරද්දී packet switch based technology එකක් adopt කරද්දී, so of course the network architecture has to be modified. හරි, the network architecture එක modify කරන්න. To accommodate this, the GPRS network architecture added new elements. Now these are the new elements introduced by the GPRS network to accommodate packet switch data. Hari, the packet switch data accommodate karanna packet switch data accommodate karanna GPRS network technology එකෙන් introduce කරපු elements දෙක or the nodes are GSM and SGSM. Right? When nodes they can introduce kara in like when you are evolving from GSM towards 3G, GPRS is the middle stepping stone. හරිද G3 2G වල ඉඳන් 3G වලට යනකොට GPRS තමයි මැද තියෙන network upgrade එක. එතකොට it is a packet based technology, right? So what is the long form of GPRS? General Packet Radio Service. So it is a packet based network technology. So everything that is circuit switched in GSM network had to be upgraded so that packet switch data can be communicated. Packet switching වලින් data communicate කරන්න පුළුවන් විදිහට GSM network architecture upgrade කරන්න ඕන, right? So for that we had to include or introduce these two new elements, GGSN and SGSN. What does GGSN stand for? Gateway GPRS Support Node, right? Gateway GPRS Support Node. And SGSN means Serving GPRS Support Node. So those are the two new introductions to the existing GSM network. So when you move towards 3G, GPRS is a stepping stone, right? So in order to implement GPRS is a packet switch technology, right? So in order to implement GPRS, we had to introduce new network elements to the existing GSM network architecture. Existing GSM network architecture කට අලුතෙන් network elements introduce කරන්න වුණා GPRS implement කරන්න. Right? So එතකොට ඔන්න ඔය අලුත් දෙක තමයි තියෙන්නේ. Gateway GPRS support nodes are serving GPRS support node, GGSN and SGSN. Okay. Then now you can see now MSC. Now this is the base station controller. This is the base transceiver station. Now these are already existing units in the GSM network. GSM network existing units in BTS, BSC. Then BSC is connected to the MSC and then GMSC and then to the other networks, right? So this is the basic GSM network architecture. එතකොට දැන් මේ පැත්තේ තියෙන්නේ GSM network එකේ පැත්ත. Now here we have three databases. Right? So equipment identity register EIR, HLR home location register, AUC authentication center. Right? So these are the three or four. VLR can also be there. So these are the three databases. Databases. So everything is introduced in the GSM technology at first. 2G වලදී තමයි මේ දේවල් ටික introduce කළේ, right? So BTS, BSC, MSC, these are the databases. So these things were introduced in GSM. Then these are the new nodes, GGSN and SGSN. එතකොට in order to implement packet switch technology, in order to implement GPRS, we need to introduce these two nodes, SGSN and GGSN. හරිද GPRS technology එක introduce කරන්න මේ තියෙන existing GSM technology එක හරිද GSM infrastructure එකේ මොනවද තියෙන්නේ? We have the base transceiver station, then base station controller. So if you remember the original GSM network infrastructure, this is what it looks like, right? So here you have BTS, then BSC, then MSC, and you have the gateway to the other networks, other communication networks. So these are the main components of the GSM network architecture. BTS, BSC, MSC, and these databases, HLR, VLR, AUC, and EIR can also be a part of it, right? So these are the, this is the basic network infrastructure of GSM. Now, when you implement GPRS, what happens? GPRS introduce new two elements to the network, right? So it is working alongside with the existing GSM network. GPRS network එක existing GSM network එකත් එක්ක වැඩ කරනවා එකට, right? And also it made use of these databases as well. මේ databases common තියාගෙන පාවිච්චි කරනවා මේ දෙකම GPRS and GSM, right? Both are interoperate. They interoperate with each other. They work alongside with each other, හරිද එකට තමයි වැඩ කරන්නේ. ඒතකොට මේක common databases ටික share කරගෙන එකට වැඩ කරන්නේ. But it introduced new two nodes to the system. That is SGSN and GGSN. SGSN සහ GGSN දෙක අලුතෙන් introduce කළා. Right? So these are packet switch data. Right? So this is the GPRS side of the network and this is the GSM side of the network. Both the GSM and the GPRS side share the same databases. හරිද? මේ තියෙන GSM side එක මේ තියෙන GPRS side එක මේ දෙකොල්ලම මේ databases ටික common share කරගන්නවා. Right? So PCU is something which switch traffic between the GSM side and GPRS side. GSM side එකටයි GPRS side එකටයි switch කරන්නේ PCU එකේ. Right? So this is the modified network architecture for implementing GPRS technology. GPRS technology එක implement කරන්න අලුතෙන් modify කරපු GSM architecture එක. එහෙම නැත්නම් upgraded GSM architecture එක තමයි මේ තියෙන්නේ. අලුත් nodes දෙකක් add කරලා තියෙනවා. What are the two nodes? SGSN and GGSN. Okay? I hope it's clear. Now we discussed up till today, we discussed about the existing GSM network infrastructure, which was which belongs to the second generation of mobile communication, right? So that is the existing GSM network infrastructure. But now we are talking about GPRS, right? So which introduced these two new nodes to the system. Okay, packet switch network. So let's take one by one and what these two do. GGSN, SGSN. SGSN, GGSN දෙක මොකද කරන්න කියලා අපි බලමු. Right? So GGSN or the gateway GPRS support node, right? So this is the long form of GGSN. We already told it. Gateway GPRS support node. It is one of the most important entities within the GPRS network architecture, right? Typically located at one of the MSC sites, and these are the main functions of GGSN. The gateway GPRS support mode. So it acts as the gateway which routes the data or the information to the outer internet. These are the main functions of the GPRS GGSN. GGSN node එකේ තියෙන functions තමයි මේ තියෙන්නේ. It will interface to external data networks. So this is the normal mobile network that we have. Then GGSN will act as a gateway between other data networks, right? Anik data networks එක gateway එකක් විදියට act කරනවා GGSN. So GGSN will connect the mobile network to the other data networks. Okay? So that is the first function. It resembles to a data network router, right? So it looks like its functionality is just like a router. This functionality is the data network router functionality. Our incoming packets, data packets, හරියට route කරන එක තමයි. එහෙම නැත්නම් හරි destinations වලට යවන එක තමයි GGSN network node එකකින් කරන්නේ in GPRS technology, right? So what is done by the GGSN network node? It will route the incoming data packets to proper destinations, right? So that is the functionality of a router. So it is not a router, but it acts as a router, right? So its functionality is kind of similar to the router. Okay? It is quite similar to the router's functionality, right? Okay, then it forwards end user data to the SGSN. So, it communicates between SGSN and other data networks. So SGSN other data networks අතර communication එකක් තමයි GGSN වලින් කරන්නේ, right? And then it filters the then routes mobile originated packets to the right destination. So this is the router's function. Router එකක function එක තමයි destination එක දීලා තියෙනවා නම් IP packet එකක, then the router will route it to the correct destination, right? So that is also the same functionality carried out by GGSN. GGSN වලින් කරන්නේ ඒ functionality එකම තමයි, right? It filters end user traffic. So it does the filtering function as well. Then it collects charging information not for data network usage. So it kinds of you know, do the billing process, right? So the charging information. Then data packets are not sent to mobile station unless the user has activated the PDP address. So this data routing, the data packet routing is the main functionality of GGSM. GGSM වලින් කරන ප්‍රධානම functionalities දෙකක් තියෙනවා. එකක් තමයි data packet routing. The other one is connecting the mobile network to the other data networks. So those are the two main functionalities performed by the GGSM. Okay, so it is a new node introduced to the existing GSM network architecture. හරිද? අලුතෙන් introduce කරපු node එක GPRS technology එක හරහා අලුතෙන් introduce කරපු node එක තමයි GGSM කියලා කියන්නේ. හරිද? ඒ GSM network එක upgrade කරේ අන්න ඒක introduce කරලා. Then SGSM. SGSM is serving Gprs support node. That is the long form for SGSM. SGSM වලට long form එක මේක. Serving Gprs support node, right? Then it provides a variety of services to the mobiles. So it will provide a lot of services to the mobile, such as packet routing and transfer, mobility management, logical link management, authentication, charging data. So these are the services provided by SGSM. There is a location register within SGSM, and and this stores information, local information, right? Location information. Location information is also stored in SGSM, right? Then different user profiles for all the Gprs users registered within the SGSM. So what it does is it does mobility management. Mobility management in that VLR functionality, right? So VLR functionality is also performed by SGSM. So mobility management means it will track the users or the subscribers who are mobile in that particular area, right? Then these kinds of services are performed by SGSM. SGSM වලින් කරන්නේ ඔය වගේ services, right? So it also does the packet routing and transfer. So anyway, these are the two new nodes introduced to the network. නේද? මේ අලුතෙන් introduce කරලා තියෙන මේ විදිහ. So if you are asked to draw the GPRS network architecture, then please follow this. Okay, GPRS network architecture, you have to follow this. Okay, so please you have to draw the GPRS network architecture like this. So if you are asked to draw the network architecture, you have to draw it like this. Okay, so this side is the GSM network components, MSC, and this side is the two new nodes that are added to the network, GSM network. හරිද? ඊළඟට PCU will do the switching, okay, between circuit switch data and packet switch data, right? So circuit switch data is transferred to the existing GSM network. Packet switch data will be forwarded to the SGSN and GGSN nodes. හරිද? Packet switch data forward කරනවා SGSN සහ GGSN nodes වලට. Circuit switch data will be forwarded to the MSC, GMSC through PSTA, okay? So this is the switching functionality is performed by the PCU. PCU එකෙන් කරන්නේ switching functionality එක. PCO packet control unit. So this is the long form for PCU. PCU වලට long form එක මේක packet control unit is a hardware router that is added to the BSC. Now it differentiates data destination for GSM network and GPRS network. ඒතර GSM network එකට GPRS network එකට අදාළ data switch කරන්න PCU එකේ, right? Then PCU itself may be a separate physical entity, or more often these days it is incorporated into base station controller, thereby saving additional hardware costs, right? So what does that mean? So PCU can be a separate hardware device, or it can also be incorporated inside the BSC. BSC එක ඇතුළෙම තියෙන්නත් පුළුවන් PCU එක. So it might be located outside the BSC, or it can be inside the BSC without needing for a separate hardware for PCU itself. The network එකේ PCU වලට separate hardware එකක් නැතුව PCU එක BSC එක ඇතුළේ implement කරන්නත් පුළුවන්. BSC is base station controller, right? So last week we did all these things. So that is the functionality of PCU. PCU will mainly switch between circuit switch data and packet switch data, right? Circuit switch data will be routed in this direction, forwarded to this direction. Packet switch data will be forwarded to the other direction. Okay. Then now Gprs will support these mobile types: Class A, Class B, and Class C. Class A, Class B, Class C mobile types වල Gprs support කරන විදිහ අපි පොඩ්ඩක් බලමු. So how the Gprs technology can be implemented in these types of mobile devices, right? So Class A mobile devices, now they can be connected to both of these networks, both Gprs and Gsm services at the same time. So they are able to get the services from both of these network types, Gprs and Gsm. Gsm and Gprs දෙකෙන්ම services ගන්න පුළුවන් Class A type එකට, right? So simultaneous Gprs and conventional Gsm operation support simultaneous circuit switched and Gprs data transfer. So both of these networks will be supported in Class A mobile types. Class B, they can be attached to both Gprs and Gsm, but not simultaneously. එකම වෙලාවෙ බෑ. වෙලාවල් දෙකකදී they can switch between Gsm and Gprs at two different times, not the same time, right? So they can't be connected to the Gprs and Gsm both at the same time, but they can be not at the same time, right? So they can be attached to both Gprs and Gsm services simultaneously, can listen to circuit switched and not the same time, okay? Yeah, not simultaneously. This can't be the case. At two different types, okay? So they both can be connected to the Gprs and Gsm network, not simultaneously, but at two different times, okay? They can listen to circuit switch and Gprs pages. So, Gprs packet switch, circuit switch data, both can be accessed by the Class B mobile types, okay? It supports either circuit switch calls or Gprs data transfer, but not simultaneous communication. දෙකම එකපාර සිද්ධ වෙන්නේ නැහැ. එකපාර Gprs වලින් services සහ Gsm services දෙකම ලබා ගන්න බෑ. හරිද? එක වෙලාවක Gsm ගත්තොත් Gprs බෑ, Gprs ගත්තොත් Gsm බෑ. But both are working in Class B mobile, right? In Class A, both simultaneous operation can be done. දෙකම support කරන දෙකම එකපාර දෙකෙන්ම services ගන්න පුළුවන් Class A වලදී. Class C කියන්නේ this classification covers phones that can be attached to either Gprs or Gsm. So these Class C mobiles, they can be either working with Gsm network or Gprs, not both, okay? Services, but user needs to switch manually between the two different types. So this is a manual switching, okay? It is not automatic. So alternatively, attached in Gprs or conventional GSM, no simultaneous operation. And sometimes class C devices, they can only support one, okay, either Gprs or GSM, right? So if the user needs to switch between the two services, then he has to do it manually switch karanna only, okay? So anyway, now this is all about GPRS. GPRS ගැන ඔච්චරයි. GPRS කියන්නේ it is a stepping stone between 2G and 3G, right? So 2G සහ 3G අතර අතරමැදි අවස්ථාවක් තමයි GPRS කියන්නේ. And GPRS has introduced higher data rates than 2G, right? It has introduced packet switching to the network, packet switching to the mobile network with the packet switching introduced kare GPRS, right? Okay, so and it introduced two new nodes and it changed the overall GSM network architecture. It can interoperate or operate alongside with the GSM network architecture. GSM network architecture එකත් එක්ක එකට වැඩ කරන්න පුළුවන්, right? So we did not need to fully remove the overall GSM network architecture to implement GPRS, okay? Then edge, right? So it is developed by Ericsson it is also a step between 2G and 3G. It is much close to 3G. 3G වලට ගොඩක් close technology එකක් තමයි edge කියන්නේ, right? So these are this is the data rate where the edge can offer. This is the data rate that edge can offer, that is 384 kbps. This means that a company who has not paid for 3G can still provide fast data services, right? So if it was operating alongside with 3G එක operate කරන එකක්, නමුත් 3G වලට වැඩිය පහළ. It is 2.75G, okay, edge, right? So even if the company has not paid for 3G, it can still get higher data rates from the mobile service, right? So higher data rates access කරන්න පුළුවන් 3G ම නෙමෙයි, 3G වලට වැඩිය පොඩ්ඩක් අඩු. That is 2.75G, that is edge, okay? Companies that have bought 3G spectrum will benefit from the infrastructure put in place for edge. Edge is also a stepping stone between 2G to 3G journey, right? 2G 3G දක්වා යන journey එකේ මැද අතරමැදි අවස්ථාවක් තමයි edge කියන්නේ. හරිද? ඒතර edge infrastructure එක තියෙනවා නම් company එකට ලේසියෙන්ම 3G වලට මාරු වෙන්න පුළුවන්, right? So it was introduced right before 3G, right? So it was introduced right before the implementation of 3G. So it is a slow transition, right? 2G වලින් ඉඳන් 3G වලට යද්දී it is a slow transition. So first came GPRS, then came edge. So mobile or any other companies that change their infrastructure to the edge network could easily go for 3G, right? Edge වල infrastructure එක තියෙනකොට ලේසියෙන්ම 3G වලට adapt වෙන්න පුළුවන්, right? So it is not a very abrupt process. ඒ කියන්නේ එකපාරට සිද්ධ වෙච්ච වෙනසක් නෙමෙයි from 2G to 3G. So it took time. It took several in between steps to transfer, right, or transition from 2G to 3G. So current infrastructure, current base stations will require a new transceiver and a software upgrade to allow edge transmission. What are the changes that have to be done? They need new transceivers, transmitter and receivers at the base stations, and a new software upgrade. So those are the requirements to implement edge, right? So this can take place as and when the normal base station are being serviced. Then obviously there are still the same issues as GPRS in respect to that channel. that is used for edge takes one away from a voice call. Okay, so yeah, yes, edge is also a packet based technology. So to implement edge, these are the modifications that had to be done to the current infrastructure. Current infrastructure has the mobile station, the base transceiver station, then base station controller, right? So then MSC and so on. So in the base transceiver station, you have to replace the transceiver with the new transceiver, which supports edge. Edge වලට support කරන අලුත් transceiver එකකින් BTS වල transceiver එක replace කරන්න ඕනේ. That is the first one. And also it has to do a software upgrade. Okay. So that is the introduction of edge. So this is edge evolution. Initially we have GSM, then Gprs, then edge. Okay, so packet switching is done through Gprs and eGprs, right? Extended Gprs. Then evolved Gprs, right? So this is the packet switching side, this is the circuit switching side. Circuit switching side, packet switching side, right? So GSM to Gprs to edge and to 3G. 3G තමයි ඊළඟට. Right? These are the two in between steps. So stepping stones from for GSM to reach towards 3G. 3G access දක්වා GSM reach කරන path එකේ මැද තියෙන steps දෙක තමයි මේක. Right? So they both support circuit data. Okay. Now, packet switching was introduced by TRS. TRS වලින් තමයි මුලින්ම packet switching introduce කරේ Gsm network. Initial GSM was a circuit switch network. Okay. Then, like these are the changes done to the Gsm network infrastructure. Base station system Gprs that was introduced. Then Gprs standards require only minor changes. So quality of services are require minor changes to the Gprs standards and minor changes to implement base station system Gprs protocol. Okay, the other changes are taking place in the layers of layer 0 of the device, right? So OSI module layer 0 and 1 වල තමයි the layer link layer, right? Those are the changes that had to be taken place implement in the network, right? Now edge and Gprs, they are interoperable with each other. They can both communicate with each other. So those are different changes that had taken place edge in Gprs network. Now edge comes Gprs, right? So small changes has to be done to the existing Gprs network architecture implement it. Okay, so you have to remember the different, yeah, so these are the specifications of edge. Edge වල පාවිච්චි කරන modulation port එක ඒ වගේ දේවල්. So you have to remember the data rates and the changes that had to be done when you imaging the network communication edge implement කරද්දී මොන වගේ changes කරන්න ඕන උනේ. So what kind of data rates are available through edge, and what is edge? It is 2.75G network upgrade, right? And it is a stepping stone towards 3G, and it supports packet switch data, right? Then these are the module formats. This modulation 8PSK is the modulation format that is used in edge, right? Yeah, so in 8SK, it transfers 3 in each modulation. 8 PSK is something I think you remember. 8 PSK matakai. 8 PSK means 3 are used one symbol. एक symbol आप return करना bits to make in 8 PSK. This is 0 0 0 0 1. Likewise 0 1 0 0 1 1. මේ වගේ combinations අපක් තියෙනවානේ. 8 PSK means that's why it stands for 8 combinations. There are 8 combinations and each symbol represented by 3 bits, right? 3 bits are represented by each symbol. It has the Gprs, and one of the reasons why edge is 3 times faster. Gprs වලට වැඩිය edge fast වෙන්නේ මෙන්න මේ හේතුව. It 3කින් එක symbol එකක් represent කරන්න පුළුවන්. So data rate has increased by 3 times. Okay. So edge is more sensitive to errors and need to be close to the transmitter to allow maximum throughput, right? So edge is more error prone. More bit error rate can be high when the edge is used. Errors can be introduced more during transmission due to the modulation formats due to increased data rates. The errors can be there. Noise, the influence of noise on the edge data can be high. Okay, so that is a downside. Okay, these are the different upgrades to the existing GSM network that was introduced from GSM to 3G evolution, right? So GSM network evolution, 2.5G, 2.5G belongs to Gprs, 2.75G is Edge, okay? 2.75 is Edge, 5G is Gprs, then 2 is GSM. Okay, see, you can see the data rate, maximum data rate evolution. The basic of all this GSM evolution is to introduce higher data rates to the system and to introduce packet switching. ඔන්න දෙක තමයි ප්‍රධානම GSM 2G network එකක් evolve වෙන්නේ හේ තමයි එකක් packet switching වලට මාරු වෙන එක අනිත් එක තමයි data rates වැඩි කරන එක, right? So this is still going on. තාමත් දැන් 4G introduce කරාම උනත් ප්‍රධානම හේතු දැන් ওই හේතු දෙක හින්දා තමයි මෙච්චර කල් mobile networks have gone through so many generations up to 5. Right, today we are experiencing 5th generation. So all these network generations, they were evolved to provide higher data rates as well as to provide to increase the capacity. System higher data rates into right, and to support IP-based network. Karanna thamai mobile networks evolved from G to 5G that we are experiencing today. Okay, so that is the basis. Now you can clearly see that when GSM offered only 9 kbps data rate, very small compared to 572 kbps, which is half of 1 Mbps data rate is offered by Edge. Edge is data rate, right? So in GSM it is a few kilobits per second. kbps කිහිපයක් 10ක් විතර දක්වා තමයි offer කරන්නේ, right? So these are maximum data rates. The real ones are even less than these data rates. හරිද? ඇත්තම data rates මීටත් වැඩිය අඩුයි. එතකොට now that was the main reason why the evolution happened from 2G to 3G. 2G series දක්වා evolve වෙන්න හේතුව මොකක්ද? With the increasing demand, with the increasing of data hungry device services, band hungry, data hungry services, and with the increasing of the system capacity. System capacity means number of subscribers. So when all these things are increasing, we need to provide better solutions to increase the data rate, to expand the network for packet switch data, right? And to support more customers. So those are the reasons why GSM evolution happened. And every step along the way towards 3G, they introduce more features to the system. Alut features introduced kara system eකට, right? So with from 2G to 3G, it took a huge it was a huge transition from 2G to 3G because 2G is completely circuit switched and 3G is packet switched. එතකොට මේකත් මතක තියාගන්න 2G to 3G transition එකේ මැද තියෙන ටෙක්නොලොජිස් දෙකක් තමයි Gprs and H කියන්නේ. හරිද? ඔය දෙකෙන් තමයි 3G දක්වා transition එක enable කරේ. Okay, so the mobile communication generations is over, right? Then mobile communication part is done. Okay, so we started off from the mobile communication. We did so many things in mobile communication. The mobile communication we at the end we discussed about different generations of mobile communication, right? Then also different the communication infrastructure started from GSM, right? And then we did a lot of theoretical parts at the end. So in the beginning, we introduced the cellular network. Cellular network is introduced kara. Then we discussed about the frequency allocation, frequency planning, frequency reuse, clusters, right? So again, deval godak kara. Then we discussed about the radio wave propagation along free space, right? So then we came to the network architecture. Then we came to the different generations and evolution of technologies behind mobile communication through generations, right? So those are the things that we did in mobile communication. So this module had a huge part which played in terms of mobile communication. Mobile communication pattara loku weight ekak tiyenawa. So not only mobile communication, we also discussed about different other technologies as well, right? So like multiple access techniques, modulation techniques. What අපි කතා කරන්නේ multiple access techniques, modulation techniques, what else? We discussed a lot of technologies, right? Spread spectrum techniques ගැන කතා කරා. So those are the other technologies associated with wireless communication systems, not only mobile. Mobile communication වලට විතරක් නෙමෙයි. අනිත් wireless communication systems වලට බලපාන technologies තමයි ඔය. හරිද? Modulation formats are common to all the wireless communication standards, right? Not only mobile communication, and then the multiple access techniques, multiplexing techniques, duplexing techniques. Those are the basics of wireless communication systems. It is common for everything, not only mobile. Mobile communication විතරන්නේ අනිත් කරන්න දැන් අද අපි කළා ඉවර කරන්නේ wireless communication systems වලට පවා වැදගත් වෙන දේවල් තමයි අපි කතා කරේ මොනවාද? The multiple access techniques, right? Different security aspects. Security aspects can spread spectrum techniques, frequency hopping spread spectrum, direct sequence spread spectrum, likewise. And then also we discussed about the multiplexing techniques, duplexing techniques, wave propagation mechanisms, right? So modes of wave propagation, path loss, fading, multipath propagation, right? So large scale, small scale. Then we also discussed about free space propagation equation. So those are very important, not only in mobile communication systems, but also in other wireless technologies as well. Okay, these are equally important. So those are the common parts that we discussed. We didn't just focus on mobile communication, although there's a heavy part that is that was taught on mobile communication systems, such as the cellular network architecture. Then we discussed about the frequency use concept, the frequency allocation, frequency reuse, those kinds of things. ඒ දේවලුත් අපි කතා කරානේ mobile communication ගැන වැඩිපුර කතා කළා. ඊට අමතරව අනිත් network technologies වලට පොදු technicalities අපි කතා කරා. හරිද? හරි. Then අපි next we go to different other wireless technologies that are being implemented in terms of wireless communication. Wireless communication wala anik technologies kana katha karanne yana. So if you have any questions regarding the things that we did up to now, we have already finished 15 lectures. This is the last one. Our theory part is done. Once this lecture is over, everything theoretically is done, right? So you have to go through the lecture slides. You can contact me anytime you want, and you can ask me if you have any issues, any questions, any problems. Then if you want me to revise all the mathematical parts in this module again, I can do it before exams, right? So exams වලට ඉස්සෙල්ලා මම ගණන් හදන්න ඕන ටිකක් ඔයගොල්ලෝ මට දවසක් දෙන්න. Still they did not inform anything about exams, right? So once the exams are finalized, we can schedule another extra lecture or two to discuss the things that we did up to now. Okay, to give you a revision lecture and also to discuss the paper, the past paper. It's not difficult at all. It covers every aspect of the whole syllabus. You can go through the past paper and you can see I have equally contributed questions from each part of the syllabus. Okay, so this year's paper is not going to be difficult as much, but it covers it will cover almost all the topics. එතකොට ඔයගොල්ලෝ පොඩ්ඩක් අර මම කොහොමත් ඔයගොල්ලන්ට කියනවා දැන් GSM network දැන් GSM කියන lesson එක ගත්තොත් you have to remember the GSM network architecture. So this is the main key point in this particular lecture. Okay, so this is the key point. So you have, once you remember this one and once you know the functionalities of all these units, then you are clear with that, right? එතකොට මේ functionalities වල එක එක දේවල් තියෙනවා. mobile equipment එක ගත්තොත් එයාගේ තියෙන මොනවාද මේ SIM එක ගැන තියෙනවා, right? Then we have other kinds of identities, right? IMSI number, IMEI number, MSISDN number. Likewise, we have different types of identity. So those can be asked, right? ඒ වගේ දේවල් අහන්න පුළුවන්. ඊළඟට now these are really nice. The things that I did at the end, these are important because I can cover, because in the past paper also you can see, I have told you how to write about VLRs, HLRs, different databases. ගොඩක් දේවල් cover කරලා තියෙනවා. So you can go through the paper, you can answer the paper by referring to the slides. ඒව බලලා උත්තර ලියලා we can allocate a separate day, a 2-hour lecture to discuss the past paper. Okay. Then we'll move to the next topic, the last topic, right? If there is time, we can discuss the things that we did. We can quickly go through the things that we did in this 16 lectures. මේ 16 අපි මොනවද කලේ කියලා මුලින් ඉඳන් අපිට quickly කරන්න වෙලාව තිබුණොත් කරමු. හරිද? Okay, so shall we first mark attendance mark කරලා ඉමු. Please tell me your registration numbers, okay? Give me a second. Number 1, number 1, base 8. Number 1 innada number 1 Vikramasinghe. Vikramasinghe. Okay, number 2.
Present, madam.
Number 2 is
KCVM
Vijay Singh. Okay, number 1 is present. Okay. Number 2 innada? Number 2?
Yes, present,
Vijay
madam.
Singh. Then number 3. Number 3 is not there, no? Number 4, Abhay Ratna.
Present, madam.
Innada? Number 4.
Present, madam.
Number 5, Ahmed. A Ahmed. Many of you are absent today. Ne? මොනහරි attendance වල issues තියෙනවනේ. ඉතින් අද දවසේ විතරයි තියෙන ඔයගලන්ට හදා ගන්න. Many of you have attended the lectures regularly. Attendance එම අඩුයි කියලා කියන්න පුළුවන්. So we have done lectures for 16 days. දවස් 16ක් කරලා තියෙනවානේ. So 80% as attendance is mandatory. දවසේ 80% කියන්නේ you have to be present for 12.8 means 13 days. දවස් 13ක්වත් එන්න ඕනේ. ඒතර දවස් 3ක් මිස් කරන්න පුළුවන්. Right? So number 1 ප්‍රශ්නයක් නැහැ. Number 2 ප්‍රශ්නයක් නැහැ. Number 2 has missed I think 4 days. But still I think it won't be an issue.
Madam, first.
But number 2 is not present today. Ne? Adat nahi. So I'm
Yes,
not
present,
too
madam.
sure whether they will be strictly following the attendance criteria this time because we are doing lectures online. ඒක නිසා attendance criteria එක strictly follow කරනවාද කියන එක මම දන්නේ නැහැ. Sometimes it will be loosened little bit because sometimes people might have technical issues to join the lectures, right? So those issues I have already noted. The power issues එම note කරගෙන තියෙන්නේ. Okay, number 2 is present. Vikash.
Madam, මම කියන එක අහන්නද?
හරිද? එතකොට ඒ වගේ මොනවා හරි ප්‍රශ්න තියෙනවා නම් මම ඒවා නෝට් කරගෙන තියෙනවා. ඒක නිසා attendance ගැන පොඩ්ඩක් අවධානය යොමු කරන්න. Number 4 Abhay Ratna. Present? 4 ඉන්නවද? Number 4.
Hello, madam.
Number 4 හැමදාම ඇවිල්ලා අද විතරක්. Number 4 present.
Present, madam.
Number 4 present. Number 5 only. 5%. Then number 10 Vinushan. Number 10%. Number 13 Ahmed. AW Ahmed.
Number 5 is present, madam.
Number 5 mark kara. Number 5. Oh, mark kara. Ahmed mark kara. Number 13. Number 13 AWM Ahmed. Innad. Number 13 is not there. Okay. Then number 14. 14 in order. Number 13. Part-time work. Okay. Number 13 I'm not present. Okay, number 14 in order. Number 14 is Nitya Ranjan. අර part time work කරන කෙනෙක් lecture එකට එන්න බැරි වුණා නම් Please, if you are recording the lecture, please share the lecture recording, okay, with him. Then number 19. Number 19, okay, present. Number 19 present. Number 20, Abekon. In another number 20. Abekon. 21, Prema Tilaka.
Yes, madam. Present.
Okay. 22, Fernando. KTH Fernando. 23, PMGS R Kumar. 23 and 24, KMH
Present, madam.
Present. Okay. Then 25, Ramsatmi. 25 and okay. Present. Then then we have 27. It's E Hoc Mode again. 27%. 27%. Okay. 28,
Present, madam.
Kumar present. Me.
Yes, sir.
29, Dilshan. Dilshan. Ingan. 29 in the. Okay, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 of you are present. හරිනේ එතකොට 13 ඉන්නවා. හරි. තව කාට හරි මොනවා හරි හේතු තියෙනවා නම් absent වෙන්න යන්න power failures එහෙම තියෙනවා නම්.
මනම් number 2 වල ප්‍රශ්නයක් නැහැ නේ මඩම් මම ඉස්සෙල්ලාම කිව්වා.
number 2 වල ප්‍රශ්නයක් නෑ පොඩ්ඩක්. දවස් 4ක් තියෙනවා හැබැයි.
මඩම් මේ 3යි ආවේ නැත්නම් මඩම් first last 3 විතරයි.
පළවෙනි එකේ ආවද? පළවෙනිම lecture එකේ.
නෑ first lecture ගන්න.
නෑනේ. ආයි 3 4 ඇවිල්ලා තිබුණේ. හරිද? 3 4 ඊට පස්සේ ආයෙත් අන්තිම එකක් නැහැ. ඒක නම් ප්‍රශ්නයක් වෙන එක ගන්නවට දවස් 4ක් කියන එක ප්‍රශ්නයක් නැති වෙයි. තව 1 2 3 අසෙන් කවුද? MH අසෙන්ගේ තියෙන දවස් 4ක්. එක විෂුව එකක් වෙන එකක් නෑ. අපි බලමු. එම් මොනාරි ප්‍රශ්නයක් තියෙනවා නම් මම ප්‍රසන්ට් මම අක්කල් හරි දෙන්න. ඊළඟට කවුද ඉන්නේ? මෙන්න මෙයාගේ ප්‍රශ්නයක් තියෙනවා පොඩි. අදත් නෑනේ. PMGS කුමාර. එයාගේ තමයි පොඩි ඉෂුව එකක් තියෙන. දවස් ඇවිල්ලා නෑ 1 2 3 4යි 5යි අදත් එක්ක 6යි. පොඩ්ඩක් බලන්න. අනිත් කට්ටිය නම් ප්‍රශ්නයක් නෑ. ඔව්. අනිත් ප්‍රශ්න නෑ. ඔය දෙන්නගේ ඔය දවස් 4ක් නැති දෙන්නගේ මට දාලා හරි දෙන්න පුළුවන් ඉෂුව එකක් නෑ. එච්චරයි. එච්චරයි. පොඩ්ඩක් අර PMGS කුමාර එයාට පොඩ්ඩක් කියන්න. දවස් 6ක් නැති නිසා ඒක පොඩ්ඩක් කියන්න. ඕගොල්ලන්ගේ strictly attendance බලනවාද කියන එක ගැන මට මොකුත් කියලා නැහැ. But last time many of them could not sit for exam due to attendance issues. Okay, 60-70% attendance they did not. I mean 80% වලට වැඩි අය තමයි ගත්තේ. හරිද? attendance අඩු නම් ඒක අර medical දීලා ඊට පස්සේ ලොකු process එකක් ඒවත් accept කරනවාද කියලා ප්‍රශ්න තිබ්බා. සමහර අයගේ attendance ගොඩක් low last time. last batch එකේ. ඒකට ඒගොල්ලන්ව exam ලියන්න දුන්නේ නැහැ. හරිද? නමුත් ඒක it was a physically present lectures I did for all of them physically කරේ lectures. ඒක නිසා සාඩ මේ පාර පොඩි මේ ඔයගොල්ලන්ට දෙන්න පුළුවන් සහනයක්. But many of your attendance is fine නේ. දවස් දෙකක් ප්‍රශ්න වෙන එක power issues එහෙම තියෙන්න පුළුවන් නිසා පොඩක් කරයට ඉන්ෆෝම් කරන්න යා මොකක්ද කියලා එක පොඩ්ඩක් ඕනනම් මැඩම් එක්ක කතා කරලා හරි එහෙම නැත්නම් බලමුකෝ හරිද එක්සෑම් නම් නොලියා ඉන්න හේතුවක් නෙමෙයි attendance right I personally don't believe like that if you can attend the lectures it's better but even if you did not attend if you can do the exams properly it's fine right ඒක නිසා අපි බලමු මොකක් හරි මොනවා හරි ඉෂුව එකක් આવුත් මට කියන්න. හරිද? හරි. Anyway, let's do the next one. Different other wireless technologies. අනිත් wireless technologies ගැන කතා කරනකොට okay. Now, other than mobile communication, we have these wireless technologies as well. Wi-Fi, Bluetooth, WiMAX, Zigbee. So we'll one by one take into consideration and let's discuss a little bit about each. Okay, not in so much depth, only some introductory stuff that we want, that we should know. The Wi-Fi is a very common technology. Okay, the long form is wireless fidelity. Okay, it is a wireless technology that uses radio frequency to transmit data through air. So we know that it is a wireless communication technology. So data transmission is done through air, right? It uses radio frequency. Radio frequencies පාවිච්චි කරනවා. So Wi-Fi standard based on these substandards. හරිද substandards මේ දෙක තුන විතරක් නෙමෙයි ගොඩක් තියෙනවා. හරිද? Number 24, did I mark attendance? Okay. පහලවක් ඉන්නේ නෝනේ එතකොට. කාගේ හරි attendance mark කරේ නැත්නම් කියන්න. Tell me if I didn't mark attendance. දැන් අද absent කට්ටිය මම කියන්නම්. Absent number 29 is absent. Okay. Then number 23 is absent. Then 20 is absent. 20 in other. 20. 20 is not there. Right? Okay. 20 is absent. Then that's all. Four people are absent. Okay. Right. So wireless fidelity, Wi-Fi. Wi-Fi has these substandards. 802.11 is the Wi-Fi IEEE standard for Wi-Fi. IEEE 802.11. මේක මතක තියාගන්න. ඒතර substandards ගොඩක් තියෙනවා. Not only these ABG, there are ABGN and many other substandards for Wi-Fi. ගොඩක් තියෙනවා. ABG ගැන පොඩ්ඩක් කතා කරමු. Right? So this is where the Wi-Fi falls. Wi-Fi is a land area network. Okay, it's a LAN. So Wi-Fi falls into this land area network category. The standard is 802.11. So today we will discuss also about personal area network, Bluetooth. Bluetooth ගැන කතා කරන personal area network වර්ගය. Okay. From LAN we talk about Wi-Fi. From MAN we talk about WiMAX 802.16. MAN, WiMAX ගැන කතා කරනවා. Those three standards we will discuss, and other than that we are going to discuss about Zigbee. Zigbee ගැන කතා කරනවා. It is a sensor based network. Okay. So these are the network standards that we are going to discuss today. Okay. From PAN we discuss Bluetooth, from LAN Wi-Fi, from MAN WiMAX, and then this is a sensor based network, Zigbee. Okay. ඔය හතර තමයි කතා කරන්නේ, and Wi-Fi belongs to the land area network category. Okay. And remember the IEEE standards for Wi-Fi 802.11. Then it is well supported, stable, cost effective. Now, like I said, Wi-Fi has several substandards, B, A, G, N, and so on. The B standard, it is a stable standard, it is a cost effective, runs into 2.4 gigahertz frequency. So, normal Wi-Fi frequency range is 2.4 gigahertz. We also call this as the ISM band. ISM band, right? Industrial, scientific, and medical frequency band. The radio frequencies that fall in this band are 2.4 gigahertz. 2.4 gigahertz වලට වැටෙන ISM band එක තමයි Wi-Fi වලින් පාවිච්චි කරන්නේ, right? So it makes it prone to interference from other devices such as microwave devices. The ISM band is a very crowded band. Okay, ISM band is used by many wireless devices. 2.4 gigahertz frequency band එක ගොඩක් wireless devices පාවිච්චි කරනවා. So this is a very important band in wireless communication systems. 2.4 gigahertz ISM band. Okay. So many wireless devices use the ISM band. The disadvantage is the security, in terms of security, and the interference. Anit frequencies, anit devices ගොඩක් ISM band එක පාවිච්චි කරන interference ඇති වෙනවා, right? So interference can occur, right? The amount of interference can be high in ISM band, and also interference from other devices. මේ ළඟ පාත තියෙන අනිත් wireless devices වලින් interference එක වැඩි. හරිද? And the other one is security breaching. So it is easy to access the information that is being transferred in ISM band, right? It limits the number of access points in the range of each other to 3. හරිද? එතකොට access points ගාන එක ළඟ තියෙන්න පුළුවන් access points ගාන 3කට වැඩිය වැඩි වෙන්න බෑ. Okay, access points, Wi-Fi access points and Wi-Fi routers. Okay, it has 11 channels. 802.11b standard එකේ තියෙන්නේ access points එක ළඟ 3ක් තියෙන්න පුළුවන්. Communication channels can be 11. Can frequencies 11කින් can channels. So frequency band එකේ තියෙන channels 11කින් communicate කරන්න පුළුවන්. With 3 non-overlapping, and these are the data rates supported by these channels, 1 to 11 Mbps, right? So this is the realistic data rate. It is less than half of the theoretical data rate. Theoretically කියන data rate එකට වැඩිය ඉතින් ගොඩක් අඩුයි. නමුත් it can support data rates up to few Mbps. Mbps යම් කිසි ප්‍රමාණයක් දක්වා data rates offer කරන්න පුළුවන්. 802.11 B standards. Okay, so use DSSS technology, direct sequence spread spectrum, DSSS. I think you remember that for security purposes. Ne? DSSS පාවිච්චි කරනවා. Okay, that is 802.11b. Then 802.11g. It is an extension of B with the same disadvantages. හරිද? එතකොට මේ disadvantages දෙකම එකයි because it uses ISM band. ISM band එකම පාවිච්චි කරන නිසා, right? 2.4 GHz. පාවිච්චි කරන නිසා security and interference ප්‍රශ්නයක් තියෙනවා. It has shorter range than 802.11b. 11b වලට වැඩිය range එක අඩුයි. හරිද? It is backward compatible with 802.11b. So it allows for a smooth transmission from 11b to G. So it is compatible with 802.11b. It is compatible, right? Transition is easy from 802.11b to G. Flexible because multiple channels can be combined for fast throughput, limited to one access point. So only one access point can be implemented in this particular Wi-Fi standard. Okay, then this is the data rate. It runs at 54 Mbps. Mbps 54ක් දක්වා data rates achieve කරන්න පුළුවන්. බලන්න data rate එක වැඩි වෙද්දි range එක අඩු වෙනවා, right? Coverage range එක අඩු වෙනවා data rate එක වැඩි වෙද්දි. So it is a basic theory. In wireless communication, the coverage range will decrease with higher data rates, right? So data rates can be up to, realistic data rates are up to 25 Mbps දක්වා realistic data rates යන්නේ. හරිද? Uses FDM or frequency division multiplexing. So these are some features in 802.11g standard. 11g වල features ටිකක් තමයි මේ data rates ගත්තොත් ඊළඟට range එක and other special features that are associated with 802.11g. Okay, then we have 11a. So it is different a little bit from 11b and 11g because of the frequency range. Okay, now it is not using 2.4 GHz. It uses 5 GHz range. 5 GHz range එකේ නිසා interference අඩුයි. හරිද? Then 802.11a පාවිච්චි කරන්නේ 5 GHz frequency range. So the interference from other devices is less. It does not operate in ISM. 2.4 GHz වල නෙමෙයි පාවිච්චි කරන්නේ 5 GHz වල, right? 802.11a. It is different than flexible. Then more access points can be co-located. Again, Wi-Fi routers and the Wi-Fi access points ගොඩක් එක ළඟ පාවිච්චි කරන්න පුළුවන්. Okay, shorter range than now range is less. Range is less. Okay, and this is the data rate up to 54 Mbps, and realistically it can achieve up to 27 Mbps. It has 12 communication channels and use frequency division multiplexing. FDM පාවිච්චි කරනවා channels 12යි data rates 54ක් දක්වා Mbps දක්වා පාවිච්චි කරන්න පුළුවන්. The main difference is it uses a different frequency band which is 5 GHz. So because of that the interference and the security is a little bit higher than B and G. B සහ G එක බලුවාම 5 GHz band එකේ වැඩ කරන නිසා interference එක අඩුයි. Okay. Then these are the different network topologies that is used in wireless networking, wireless Wi-Fi network, right? So point-to-point topology, point to multi-point, multi-point to point, right? So I don't think I need to explain all these further. Point-to-point means you can directly communicate between two, one transmitter, one receiver, direct communication between both. Point to multi-point means transmitter is communicating with multiple receivers. Okay. Multi-point to multi-point means multiple transmitters can communicate between multiple receivers. Okay. So these are the 3 wireless network technologies. Okay. Then it is not only common for Wi-Fi, it is common for many other wireless communication වලම ප්‍රධාන topologies තුනක් තමයි. හරිද? Not only for Wi-Fi, it is common for other wireless technologies as well. Okay. Then we have these operating modes for Wi-Fi. Wi-Fi operating modes තුනක් තියෙනවා. Now these are important. Infrastructure mode, peer-to-peer ad hoc mode and wireless mesh mode. ඔය තුනෙන් තමයි මේ access points එහෙම නැත්නම් Wi-Fi routers operate වෙන්නේ, right? Infrastructure mode, ad hoc mode and wireless mesh mode. Okay? Infrastructure mode කියන්නේ මොකක්ද? Now clients, wireless clients are us, right? So wireless router is the access point. හරි access point එකක් හරහා මේ network එකට wireless clients ලා join වෙන එක තමයි infrastructure mode කියලා කියන්නේ, right? Wireless clients interconnect via an access point. Okay, configuration of access points to share the same SSID allows wireless clients to roam between basic service areas. So actually now this I will explain it in the next slide. Now the first mode, the infrastructure mode, we can go through this. This is the infrastructure mode. Now BSS is basic service set, right? Basic service set. Now this is the area covered by this access point. This is the first access point. This is the second access point, right? And this is the area covered by the first access point. And this is, that area is called the basic service set. Okay? එකට කියනවා basic service set එක කියලා. Kumar, PNG's Kumar, number 23. Number 23. Okay, so here in the infrastructure mode, this is now this access point will publish a ID which is known as the SSID, right? So SSID එකක් access point එකට. So through the SSID only our devices can connect to the wireless network. දැන් අපි SSID එක පාවිච්චි කරනවානේ අපේ Wi-Fi router එකට connect වෙන්න. Likewise, so we need an SSID to connect to the network. Okay, so this is this part, this coverage, this area covered by one router is known as the basic service set. Okay, and then another router, it has a different same SSID. It has the same SSID, but the different their device IDs are different. Okay, device IDs are different, but their SSID can be same. So when for two networks which have the same SSID, for two access points which have the same SSID, that second access point coverage area is also known as the basic service set 2. Okay, it is a different basic service set. It is a different service set. Okay, two distinct access points with same SSIDs. They can communicate with each other. Okay, but both of these access points cannot communicate directly with each other. They have to be connected to this distribution system. Distribution system එක හරහා තමයි access points අතර communication එකක් සිද්ධ වෙන්නේ. හරිද? But the clients can roam between both basic service sets. The service sets දෙක අතර clients ලට roam වෙන්න පුළුවන්, right? Let's take one by one. Basic service set. This consists of a single access point interconnecting all associated wireless clients. So basic service set එකේ හරහා තමයි access point එකට wireless clients ලා join වෙන්නේ. Right? Then basic service area, BSA. This is the area that is bound by each access point signal. එතන මේක තමයි basic service area එක. This is a basic service area. Okay? BSA is also called the cell, right? So this is called a cell. The coverage area for Wi-Fi access point is called a cell. Okay. Then basic service set identifier, BSSID. BSSID means it is a device identifier, right? A machine readable identifier for the access point. It is kind of in the format of a MAC address, and it is usually derived from the access point's wireless MAC address. එතකොට මේකේ device address එක තමයි මේ තියෙන්නේ, right? So there are two device addresses. Device addresses are different, but the SSIDs are same. Okay. Then service set identifier, SSID. This is a human readable non-unique identifier. It is not unique. It is used by the access point to advertise its wireless service. Okay. So it is not a unique one to a device. Same name, same SSID can be there. Okay. Then distribution system. Access points connect to the network infrastructure using a wired distribution system, such as Ethernet. The Ethernet වගේ distribution system එකක් කරහා Ethernet වගේ wired connection එකක් කරහා distribution system එකට මේ access points connect වෙනවා, right? An access point with the wired connection to the distribution system is responsible for Ethernet. Access point and distribution system communicate through Ethernet. That is the 802.3 standard. Make a 802.3 standard, right? And this is 802.11 standard, which is the wireless communication between the access point and the client. Clients are access point at the 802.11. Communication access point and the distribution system communicate via 802.3. Okay. Then extended service set. When a single BSS provides insufficient coverage, two or more BSS can be joined together through a common distribution system into an extended service set. So if you want to extend the coverage range, it acts as a repeat. That may make a repeat එකක් විදියට පාවිච්චි වෙනවා. So if you want to extend the coverage range of this particular access point, you can use another access point which is connected to the DS distribution system, and then you can extend the coverage range, and that is called extended service set. Extended service set. This can act as a repeater. Okay. So this is used to extend the service area or the BSA, right? Basic service area coverage further. Okay. Then my client can freely move between this access point and this access point. They have the same SSIDs. එකම SSID එක තියෙන දෙන්නටම එතන මගේ client can move freely in this particular area without any disconnection. Disconnection එකක් සිද්ධ වෙන්නේ නැතුව මේ area එකේ move වෙන්න පුළුවන්. Right? I have just extended the coverage of the access point further. Access point එකේ coverage එක extend කරලා තියෙනවා මෙතන. හරිද? But the two routers are different. Wireless access points are different. Okay, this is one, this is another one. They have two different device IDs. Device IDs දෙක වෙනස්. නමුත් එකම network එක. Same wireless network. Because they have the same SSIDs. I have just used 2 access points to extend the network, right? So only one access point, the coverage area is known as basic service set. So එක access point එකක් විතරක් තියෙන coverage area එකට කියනවා basic service set කියලා. හරිද? ඒ service set දෙකක් එකට එකතු කරන්න පුළුවන් අපිට range එක extend කරන්න. Coverage range එක extend කරන්න. ඒතර එකම network එක. You do not have to separately log in or you do not have separate permission to access the service from the access point 2. මේ access point 2 වලින් services ගන්න separate permission අවශ්‍ය වෙන්නේ නැහැ. Because they are belonging to the same network. Okay, they belong to the same network. It is just it acts as a repeater එකක් වගේ වැඩ කරන්නේ. කියන්නේ තමන්ගේ network එක තවදුරටත් extend කරන එකක් තමයි කරන්නේ. එකම network එක, right? Now that extended service is known as extended service set. අන්න එහෙම network එක extend කරපු එකකට අපි කියනවා extended service set කියලා. Okay, that is known as the extended service set. Okay, then when a single BSS provides insufficient coverage, 2 or more BSS can be joined to common DS into an ESS. ඒ කියන්නේ BSS දෙකක් හෝ කිහිපයක් එකට DS හරහා distribution system එක හරහා join වෙලා extended service set එකක්. එහෙම නැත්නම් ESS එකක් හදා ගන්න පුළුවන්. Right? So an ESS is the union of 2 or more BSS interconnected by a wired distribution system. Each ESS is identified by a SSID and each BSS is identified by its BSSID. එතකොට BSS එකක තියෙන්නේ BSSID එක. Now this BSSID is common to the device. It is the device ID. BSS එකට common unique identifier එක device ID එක. හරිද? BSS එකට common unique identifier එක device ID එක. SSID එක තියෙන්නේ ESS එකක. තේරුණාද? ඒ කියන්නේ එක router එක Wi-Fi access point එකකින් විතරක් අපිට කියන්න බෑ එයාට personal network එකක් තියෙන කියලා. හරිද? එයාට විතරක් unique network එකක් තියෙන කියලා අපිට කියන්න බෑ එක access point එකකින් විතරක්. හරිද? access point කීපයක් එකට connect වෙලා තියෙන්න පුළුවන් එකම network එක දෙන්න. එකම network ID එක. දැන් now for example if we are providing a certain wireless access to your building එකට wireless access දෙනවා. හරිද? ඒ access දුන්නාම එකම SSID එකනේ අපි පාවිච්චි කරන්නේ. We are not using multiple SSIDs, right? To log on to the network, we use only a single SSID, but we have multiple access points in a building. Building එක ඇතුලේ access points ගොඩක් තියෙනවා. නමුත් එකම SSID එකෙන් අපිට පුළුවන් let's say your university has a certain wireless network, internal network, and it has multiple access points located in multiple locations, but it has only one SSID. Ekka SSID can be, right? So it has only a single SSID, and we can join from any area, right? Or through in the building or in the campus, right? So that means it is an extended service set. It is a good example for an extended service set. Extended service set එකකට උදාහරණයක් එක. අර access point කිහිපයක් මේක building එක තියෙන්න පුළුවන්. නමුත් එකම network එකට අපි connect වෙන්නේ. හරිද? The network එකේ SSID එක සමානයි. So SSID is unique for one extended service set. ESS එකකට තමයි SSID එක unique වෙන්නේ, right? But BSS don't have the uniqueness in terms of SSID. So BSS එකක SSID එක නෙමෙයි unique, මොකද්ද? device ID එක. Right? In a BSS, device ID is unique, not the SSID. I don't have any issue with that. I'm the client, I'm the Wi-Fi client. I want to join a network in a building and there are multiple access points. I don't have any issue. I have to only log in once using the SSID. That's all, right? If the password is given to me and if I know the password and if I know the name of the SSID or if I know the SSID and password, then I can log in just once and that's all. And I can roam all over the building or all throughout the building without any hindrance or interruption. I don't have to log in again and again and again from moving from one access point to another. නේද? එක access point එකකින් තව තැනකට යද්දි මම ආයි network එකට වෙන ID එකක් දාලා log වෙනවද? නැහැ. හරිද? නමුත් ඔය එක access point එකකින් cover කරන්න පුළුවන් යම්කිසි area එකක් තියෙනවා. ඒකට කියනවා basic service set එකක්. හරි? මේ access point මේකකින් cover කරන්න පුළුවන් එක area එකක් තියෙනවා. තව එකකින් තව area එකක් තියෙනවා. මේ range එක coverage range එක වැඩි කරන්න පුළුවන් අපිට access point වැඩිපුර ප්‍රමාණයක් එක ළඟ connect කරලා. හරිද? ඒ කියන්නේ continuous wireless access එකක් අපිට දෙන්න පුළුවන්. wireless network එකක් continuous network එකක් අපිට uninterrupted wireless access එකක් දෙන්න පුළුවන්. එකපාරක් ලොක් වුණාම නැති network එක, right? So we do not have to log in again and again if you are moving from this access point to this access point. I log වෙන්න ඕනේ නැහැ. blind spot හරහා යද්දී නම් log වෙන්න ඕනේ. මොකද service area එකක් service නැති area එකකින් නම් තව තැනකට යද්දී සමහර වෙලාවට ආයෙත් log වෙන්න වෙනවා. නමුත් when you are moving from the between the basic service areas, you do not need to log into the network again and again because network ID is same. SSID is same, right? So if you know the password, if you are an authenticated user, then you can use your password to log into the network and the network service will be available throughout the floor or the building or the campus, right? එතකොට දැන් මේ access point අතර වෙන සංග්‍රහණය කොහොමද? Because of from their device IDs or BSS IDs. එයාට කියනවා BSS IDs කියලා. එතකොට this extended network with different access points which give the access to the same network. එකම network එකට access points ගොඩකින් access දෙනවා නම් අන්න ඒකට කියනවා extended service set එකක් කියලා. So all these access points are connected to one centralized system that is called the distribution system, right? Distribution system will connect all these access points to the external internet or other networks. Okay? Right. It's the infrastructure mode. Then peer-to-peer ad hoc mode. Ad hoc mode, there is no centralized access point. So it has an independent basic service set or IBSS. Ad hoc mode, it is also a wireless LAN area network. And ad hoc mode, IBSS, independent. Now here, the difference between this one and the ad hoc mode is, this is centralized. This is always client has to communicate with another client through the access point. තේරුණාද? මේ client ලා දෙන්න අතර direct communication එකක් සිද්ධ වෙන්නේ නැහැ. මේ client මෙයාට මොනවා හරි යවන්න ඕන නම් network එක හරහා තමයි යවන්නේ. එහෙම නැත්නම් access point එකත් එක්ක විතරයි client ගනුදෙනු කරන්නේ. ඒතර access point එකට තමයි මෙයාට ඕන ටික access point එකට දීලා access point එක distribution system එක හරහා නැවත මෙයාට route කරනවා. Right? So this client cannot directly communicate with this client. It has to communicate with its access point, right? An access point will do the communication between these two. There is no direct link. Okay, but in case of ad hoc mode, the client, there is no client or service access point concept. Okay, there is no centralized access point. All can be clients, all can be access points, right? They can communicate between each other. Wireless devices, other communication කරන්න පුළුවන් in ad hoc mode. Or we also call it as independent basic service set. IBSS කියලා කියනවා. Right? So IBSS stands for Independent Basic Service Set. Two devices connected wirelessly in a peer-to-peer manner without the use of an access point. ඒතර access point එකක් නැතුව peer-to-peer communication එකක් සිද්ධ වෙනවා in ad hoc mode. Okay. One device takes the role of advertising the wireless network to the client. So, but the thing is, the requirement is your device should be transmitting as well as receiving. Receive wireless signals receive වෙනවා වගේ wireless signals transmit කරන්න පුළුවන් වෙනවනේ device එකට. It should have an antenna, right? So as much as it can receive, it should also be able to transmit. Transmit කරන්න පුළුවන් වෙන්න ඕනේ, right? So if it is a transceiver, then of course it can join to the network through ad hoc mode. Ad hoc means what? Ad hoc කියන්නේ මොකද්ද? ඒ වෙලේ ඇති වෙනවා, ඒ වෙලේ නැති වෙනවා, right? ඒ වෙලේ ඇති වෙනවා, ඒ වෙලාවේ network එක create කරගන්න. It is a dynamic mode. So it can create network on the spot, right? So this ad hoc mode is important in vehicular communication, wireless ad hoc networks, right? There are specific type of networks called wireless ad hoc networks. It is not like the normal computer networks that we know about, right? So in normal computer networks that we know about, they are fixed, right? Or they can also be mobile, but not completely mobile. Not everything is moving. Okay, access points are not moving. Okay, they are fixed. And then we can, access the network, wireless network. There is a certain amount of mobility, so to a certain extent. හරි සාමාන්‍ය අපි ඕනෑම wireless network එකක් ගත්තොත් mobility තමයිනේ wireless network වල ප්‍රධානම දේ. හරි mobility ඕනකට වැඩි තියෙන්න බෑනේ. හරි. මොකද දැන් access point එක තැනක fix කරලා තියෙනවා. එතනින් එහා service area එකෙන් එහාට මට මගේ device එකේ නැත්නම් මගේ client cannot move beyond the service area of the access point, right? That is the normality or normal norm. But here in ad hoc mode, everyone is moving. Everyone is moving, and everyone who are near to each other can form an instant network. And they can also break from the network whenever they need. And they can form another instant network. So it is a dynamic kind of a wireless access mode. Wireless network access mode is dynamic. It is not static. It is dynamic. So mobility is very high. So the chance for mobility is very high. So, like in normal communication data networks that we have day-to-day lives that we are using through access points and all that. So the mobility is quite restricted. The mobility is product restricted. ඒක නිසා අපිට සාමාන්‍ය data networks කියලා ගත්තොත් the routing protocols that we use in a normal what should we say, the uncertainty or randomness is less. අහඹුතාවය අඩුයි. සාමාන්‍ය data network එකක් ගත්තොත් අපි දන්නවා මේ devices මේ network එකේ මොන විදිහටද locate වෙලා තියෙන්නේ, right? So we kind of know it has a certain mobility, but still we have a certain idea. So randomness is quite less. But in case of ad hoc networks, randomness is very high. හරිම හම්බුයි. Then, for example, vehicular ad hoc networks. So VANETs we call, right? VANETs කියලා අපි කියනවා vehicular ad hoc networks. So vehicles are moving in a highway. Let's say there's a freeway and multiple vehicles are moving, and they will instantly form networks between each vehicle during their motion. හරිද? Move වෙන ගමන් ඒ ආවට තියෙන vehicles එක්ක network එකක් හදාගන්න. It is not permanent. So depending on different speeds of the different vehicles, the network can break. Again, it can be, my car, if my car is moving along a freeway and I'm forming an ad hoc network between other vehicles surrounding me, then I can immediately form a network between 5 other cars, right? Then depending on my speed and the other speed, the network can prevail for 1 minute, and then I'm moving and I can make another network between other several other cards, right? Likewise, ad hoc network means it is a on-the-go network, right? So it can break and make and break, right? It can make and break at the same time. So the ad hoc, there is a specific meaning for the word ad hoc. Let me tell you that. When necessary or needed. So that's the meaning. Ad hoc means created or done for a particular purpose as necessary. යම්කිසි අරමුණක් වෙනුවෙන් ඒ වෙලාවේ අවශ්‍යතාවය අනුව හදාගන්න දෙයක්. That is what ad hoc means, right? Ad hoc කියන්නේ අන්න ඒකයි. ad hoc කියන්නේ එක random. Randomness is high in case of ad hoc. හරිද? ඒතර බලන්න for that to achieve ad hoc networking, you do not need a centralized communication. Centralized communication එකක් තිබුණොත් ඒ කියන්නේ එක්කෙනෙක් හරහා අපි හැමතිස්සෙම එක්කෙනෙකුට report කරන්න ඕනේ. අපිට wirelessly තව client කෙනෙක් එක්ක independently කතා කරන්න බෑ. අපි යන්න ඕනේ හැමතිස්සෙම access point through. හරිද? AP හරහා. එතකොට access point through යන්න ගියොත් mobility එක අඩු වෙන්න බෑ. මොකද access point කියන එක හරහා අනිත් clients එයාට communicate කරලා එයා තමයි ගිහිල්ලා අනිත් අයට ඒක route කරන්නේ, right? So mobility is less. But in this case, mobility is very high. Each client can communicate with other surrounding clients without any centralized control. That is called ad hoc mode, independent basic service set, in other words. Okay. So one device takes the role of advertising the network to the client. So if I want to get connected to the surrounding clients, then I should advertise my network, right? So I should broadcast the beacons. I can advertise my network. Then others will hear the beacons and they will respond. So anybody who wants to connect to the network with me, then they will respond. Okay. The IBSS allows two devices to communicate directly without the need for any other wireless access points. Access points are the centralized devices වලට කතා කරන්නේ නැතුව කෙලින්ම තව කෙනෙක්ට කතා කරන්න පුළුවන් විදිහක් තමයි IBSS. And that is the main feature. It can connect up to 10 devices together. So there is a limitation. You cannot unlimitedly get connected. You can connect up to 10 devices together. Okay, in wireless ad hoc mode, right? So it is very important in vehicular ad hoc networks. It is something that is still in the research phase because the randomness is very high. We can't use the routing protocols and other kinds of communication protocols that we use for normal data networks. We have to modify them. The master-slave architecture, usually the master is not moving, right? So slave is moving from here to there. So in a master-slave architecture, slave is the mobile one usually, and the master is not moving, right? So in that case, routing is not that difficult, okay? But in this case, routing is very difficult because you don't know. Sometimes your master can be the slave can be the master. So anyway, routing is quite difficult. So if you want to send data packets between my device and to another device which is mobile and which is which does not have any centralized control, right? I'm just directly communicating with the other client. Then of course, data packets can be lost easily, right? They can be lost secretly because I'm also mobile, that person is also mobile and very random, right? You don't know the location. Like if you want to see in case of ad hoc networks, බලන්න මෙතන තියෙන ප්‍රශ්නේ මොකක්ද? දැන් මෙතන මගේ there let's say we have several nodes, network nodes. Okay, so now we have formed an ad hoc network on the go, right? So I want to send some information to this one, right? So I can either now, if I want to route the information, I need to go through this one to this one, right? So but the thing is, this can move fast. This can also move fast. So when the packet arrives this node, this might have changed its location. So it's quite difficult. So you have to introduce different kinds of wireless technologies, or you have to routing protocols. Routing protocols තියෙනවා එක එක මට හරියට මතක නැහැ. There can be different kinds of routing protocols, such as, just give me a second. Yeah, it's a complete, yes. WRP, wireless routing protocol. DSDV. DSDV is destination sequence distance vector. So likewise, yeah, ad hoc routing protocols, there are multiple routing protocols which are quite popular also, right? WRP, staff routing protocol. Now, every of these routing protocols are quite dynamic. එතකොට මේක පොඩ්ඩක් එච්චරම සාර්ථක dynamic routing protocol, right? So ලොකුවටම සාර්ථක මේ communication system එකක් නෙමෙයි. It is a on the go communication system. It has a different motive behind it. හරිද? ඒක කියන්නේ අර dynamic environment එකක වැඩ කරන communication mode එක, right? So this is mostly used in vehicular ad hoc network. So vehicular intervehicular communication වලදී පාවිච්චි කරන, and IoT based or Internet of Things is also incorporated in ad hoc mode. Okay. So anyway, in ad hoc mode, what you need to remember is there is no centralized control, right? Centralized control එකක් නැහැ. Then mesh mode. So having a wireless distribution system connecting all IPs is not always practical. Instead, access points can be configured to connect in mesh mode, right? So they can be connected in mesh mode together. They can be connected together in mesh mode. The හැමතිස්සෙම දැන් in case of intras, this is not ad hoc. Make ad hoc නෙමෙයි. හරිද? දැන් wireless access points එකිනෙකා අතර communication එක mesh mode වලදී. හරිද? දැන් මෙතන බලන්නකෝ, in this case you see this access point cannot directly communicate with this access point, right? It has to go through this centralized system. Distribution system එක හරහානේ මෙයාට communicate කරන්න පුළුවන් in infrastructure mode. හරිද? Ad hoc mode is something different. There are no access points at all in ad hoc mode. But in mesh mode, they are allowing to communicate between different access points, wireless access points together, without having to communicate through a distribution system. Distribution system එකක් හරහා communicate කරන්න නැතුව access points කීපයක් හරහා එකිනෙකට communicate කරන්න පුළුවන් method එකක් තමයි mesh mode කියන්නේ, right? So having a wired distribution system connecting all access points is not always practical. Instead, access points can be configured to connect in mesh mode. Okay. So each access point in the mesh maintains a basic service set on one channel used by wireless clients. Then the access points bridge between each other using other channels. So anyway, this is a vast topic, right? Wi-Fi is not a easy. I mean, it's a complete module. Okay, infrastructure mode, peer-to-peer ad hoc mode. Ad hoc networks is a complete another module, right? So it consists of many advanced theories, many routing protocols that we need to study, a lot of principles and theorems and randomness probabilities. So ad hoc mode, okay. And then we have infrastructure mode, and all these three, it belongs to a huge wireless access module. So in CCNA wireless, this is the syllabus for CCNA wireless. Okay, in CCNA wireless, it will completely talk about the whole CCNA course is talking about these access points, right? Access points and how they are connected together, which kinds of modes they are operating at, and what kinds of networks they are forming, what kinds of routing protocols they are using, and what kinds of security methods or encryption methods they are using, authenticating, encrypting methods, right? So see, that whole CCNA is focused on the wireless land area networks, right? And these are the three basic modes that they are discussing in the wireless CCNA wireless. Okay. So if you are interested, you can go through that. Then we have Bluetooth. Bluetooth is a data sharing kind of a smaller network, smaller wireless network that we have already, all of us have used at least once. Okay, Bluetooth. So Bluetooth has a wireless standard of 802.15. Okay, so it is a personal area network. Bluetooth can a personal area network. Bluetooth is a short range, so it is the shortest range. It has the shortest range. It is a short range wireless technology that is used for exchanging data or file transfer between two devices, right? Using UHF radio waves. So these are the frequencies that are used in Bluetooth communication. Bluetooth network එක පාවිච්චි වෙන්නේ මෙන්න මේ frequencies 2.402 GHz to 2.48 GHz and building personal area network. So it is a personal area network which does short range communication. So it is mainly used as an alternative to wireless connections. Either to exchange files between nearby portable devices and connect cell phones and music players with wireless headphones. So these are, we have already used these services from Bluetooth technology, right? So you know why the Bluetooth is being used, right? Mainly to do file transfer between two devices which are close to each other. Okay. Two wireless devices. Wireless devices දෙකක් අතර communicate කරන file transfer කරන the wireless devices are located close to each other. Okay. Then this is the symbol usually used for Bluetooth. Bluetooth is managed by this task group, that is special interest group, SIG. Okay. So they are the ones who have developed the technology and who are maintaining the technology, right? Standardization is 802.15.1. You have to remember the IEEE standards for different technologies. Then Bluetooth uses radio technology called frequency hopping spread spectrum, FHSS. Monkey FHSS කියන්නේ මොකක්ද කියලා. FHSS means with time the frequency hopping is done. No, the transmission frequency is changed. Transmission frequency එක වෙනස් වෙනවා කාලයත් එක්ක. That is called frequency hopping spread spectrum, right? Then Bluetooth divides transmitted data into packets and transmits each packet to one of 79 designated Bluetooth channels. So there are 79 Bluetooth channels. Then each channel has a bandwidth of 1 megahertz. Okay, megahertz එකක bandwidth එකක් තියෙනවා each channel, right? So these are the specifications for Bluetooth. Bluetooth specifications matrix, right? So always remember the Bluetooth standard IEEE 802.15.1, right? And then let's see the network architecture. Bluetooth network architecture බලමු, right? It is a packet-based protocol with master-slave architecture. Network architecture is basically a master-slave architecture. Master-slave architecture එකක් තමයි තියෙන්නේ, right? So one master may communicate with up to 7 slaves in a Piconet. So there are some new words that you will see in Bluetooth network architecture: Piconets and Scatterings. Okay. So this is a Piconet. Piconet means there is one master device and it will connect with up to 7 devices, 7 slaves. So all the devices that are connected to a Bluetooth network is 8. හරිද? Bluetooth network එකට connect වෙන්න පුළුවන් සම්පූර්ණ devices ගන්න 8යි. එක master එකක් slaves 7ක් එක්ක communicate කරන්න පුළුවන්, right? In a Piconet. එතකොට අර හැදෙන small network එකට කියනවා අපි Piconet එකක් කියලා, right? That small network that is connecting 7 slaves to one master is called a Piconet. Okay? The devices can switch roles by agreement. So master at one time can become a slave, right? The master is not permanent, slave is not permanent, so masters can become slaves, slaves can become masters, but one Piconet should have one master and others are slaves, right? The devices can switch roles by agreement and the slave can become the master, okay? All devices within a given Piconet use the clock provided by the master as the base for packet exchange. So there is a clock that is set by the master. So based on the clock, the packet exchange is done. Okay. So this is the network, basic network architecture of Bluetooth. Right? There is the Piconet 1, 2, and there is a bridge slave. This will bridge between the two devices, two Piconets. Piconets දෙකක් අතර bridge කරන්නේ මෙහෙම මැද තියෙන එක slave එක, right? So this is the master and this is the slave, right? And this overall one is called the scatter net. These two Piconets together is called the scatter net. Scatter net එකක් කියලා කියනවා මේ දෙකේ දෙකට. Scatter net, right? The එක Piconet එක බලන්න එක master එකයි slaves ලා ටික. හරිද? එක master එකයි slaves ලා ටික. There can be 7, up to 7. So two Piconets can be bridged together through a bridge slave. Bridge slave එකකින් bridge කරන්න පුළුවන් Piconets දෙකක්. So once the two Piconets are bridged together, that is known as the scatter net. Okay, so this is the basic Bluetooth network infrastructure or architecture, right? So if you are asked to draw the Bluetooth network architecture, you have to mention all these, the names of the Piconet, scatter net, master, slave, all these things. Okay. So here you can see, this is the Piconet 1, Piconet 2, and there is a common slave between the both, and the overall one is called the scatter net. Okay. Then 8 devices can be considered in a Bluetooth network called Piconet. Like I said, there is one master, 7 slaves. So 8 devices ඇතුළේ තියෙන කොහමද? One master, 7 slaves. One master and 7 slaves makes the 8 devices in a Piconet. Piconet take 8 devices අටක් තියෙනවා. One of them acts as a master and others acts as a slave, as slaves. Okay. A scatter net is formed when 2 or more Piconets connect through a bridge node. Bridge node එකක් කරා connect වෙනවා, in which certain devices simultaneously play the master and the slave. Now here, this bridge node can act as a slave to this Piconet and master to the other. හරිද? මේ slave මේ bridge node එකෙන් එකක slave කෙනෙක් අනිත් එකේ master කෙනෙක් වෙන්නත් පුළුවන්, right? So that can also happen. Okay, all the communication is between master and slave and not between the slaves. This is important. So this is quite different from the ad hoc networks. Ad hoc networks can communicate between other devices without any issue, right? So but here the communication should always be done between the master and the slaves and not between the slaves. Slaves අතර communicate කරන්නේ නැහැ. Okay. So always the master is appointed, and after that master will do the data distribution. So it will slaves will communicate with the master, and master will do the data communication, right? So this master in one place can become a slave in master in one Piconet can be a slave in another Piconet, right? So if multiple Piconets are bridged together, that is called a scatter net. Piconets ගොඩක් එකට bridge වෙලා තියෙනවා. ඒකට කියනවා scatter net එකක් කියලා. හරිද? එක Piconet එකක master කෙනෙක් අනිත් Piconet එකේ slave කෙනෙක් වෙන්න පුළුවන්. එතකොට හැමතිස්සෙම slaves අතර communicate කරන්න බෑ. හැමතිස්සෙම slave අතර communicate කරන්න නම් master හරහා තමයි communicate කරන්නේ. Right? Always communication is between the master and the slave, not between the slave and the slave. Okay? So most Bluetooth applications are battery powered class 2 devices. So these class 2 devices communication range is up to 10 meters. So that you can access Bluetooth service or Bluetooth connection to a distance up to 10 meters, right? So, but there are class 1 devices which provide Bluetooth connections up till 100 meters. Meters 100 දක්වා can extend කරන්න පුළුවන්, right? Transmission power is usually 1 milliwatt. Okay, so these are the specifications in Bluetooth technology. Bluetooth specifications, right? Then WiMAX. Any questions from Bluetooth? Bluetooth වලින් ප්‍රශ්න තියෙනවද? Wi-Fi and Bluetooth, those are important network types, wireless network types, right? Then we have WiMAX. So I hope you must have heard about broadband access, broadband network access, right? So in broadband access, now in the public switch telephone network or land phone network, you know the last mile network. Last mile network again done. Last mile network means the network between the telecom central office and the users, subscribers. Subscribers are central office network last mile network, right? So this last mile network can provide broadband access. That is called the broadband network. Okay. So usually we have the telecom central office, then we have subscriber home, and the network or the it is only a few kilometers long, right? So that network is not called the last mile telecom network, right? This last mile network can be a wired network or a wireless network. If this is providing broadband access, it can be a wired broadband access or wireless broadband access, right? Wired broadband access means the broadband access through copper wires, which is called the DSL connections, DSL, right? So you must have heard about it, digital subscriber line. That is a technology which provides broadband access to through public switch telephone network, right? So DSL. Now, DSL is a wired copper wire based technology, and the other broadband access network is optical fiber based broadband. That is called the passive optical network or PON. You may have heard it, PON or GPON or EPON. We have different types of passive optical network types. That is the other wired broadband access. And the other broadband access is wireless broadband access, which is WiMAX. Then now we have the last mile network, like I said, last mile network. Let me show you just let me show it to a figure, okay? Last mile broadband access. Yeah. Give me a second. Right. So last mile broadband access කතා කරාම මෙන්න මේ වගේ Dilshan, I didn't mark your attendance, right? Dilshan, can you tell me your registration number? Who joined the lecture just now? 27 or 29? Can you put it in the chat?
29.
Okay, 29. I didn't hear you properly, but anyway, 29, I think, right? Okay. Anyone who joined now? කවුරු හරි මොන හරි network ප්‍රශ්න නිසා දැන් join වෙලා තියෙනවා නම් කියන්න, right? So I'll announce the absentees names again. Abekon is not present. Number 20. Abekon. Innada. Then that's all, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 are present. හරිද? එතකොට තව ආවේ නැත්තේ අබේකෝන් විතරයිනේ. Okay. Last mile broadband access. So here you can see, okay, it's not that clear. Just I'll tell you, right? So the middle mile of a network, telephone network means this is the core network, right? Core network, this is the middle mile, and this is the last mile, right? So last mile has our telecom exchange. Last mile means from telecom exchange to the subscriber, right? Telecom exchange to the subscriber is the last mile. Last mile network again, this is the telecom exchange. Telecom exchange to the subscriber. These are subscribers. This is the small network segment. Last mile, antima mile එක. අන්තිම කිලෝමීටර් ප්‍රමාණය තමයි ටෙලිකොම් නෙට්වර්ක් එක අන්තිම කිලෝමීටර් ප්‍රමාණය තියෙන නෙට්වර්ක් එක තමයි last mile network කියන්නේ. හරිද? ඒතර broadband access network එක මේක. This is the broadband access network. So this broadband access network can be Wi-Fi used. Fiber can be used. So if fiber is used, it is a passive optical network, PON. If DSL connections are there are different types of DSL networks called ADSL, VDSL, SDSL, HDSL, SHDSL, likewise, right? So DSL means copper wire based, coaxial based network. And the wireless broadband access is WiMAX. This is the one that we are talking about. Wireless broadband access network, WiMAX. WiMAX. Which is where WiMAX is in the overall network. Now, overall network has a core network, middle mile, and then last mile. Okay. Now, the middle mile can be the aggregation network. This is the core network, right? Okay. Anyway, WiMAX. This is the long form for WiMAX. WiMAX is a long form maker. Worldwide interoperability for microwave access. This is the long form for WiMAX. Wireless MAN. It is a metropolitan area network. Now we discussed about personal area network, which is Bluetooth. Wide area, land area network, which is Wi-Fi. මේ දෙකම අපි කතා කරන්නේ 802.15. This is 802.11. This is WiMAX 802.16. Okay, Hyperman. WiMAX. WiMAX is a metropolitan area network. Okay, this is the IEEE standard 802.16. It is a wireless broadband access network. So WiMAX would operate similar to Wi-Fi, but at higher speeds. Wi-Fi is a smaller network, smaller range, less speeds at the Wi-Fi wala. WiMAX කියන්නේ wireless network data network access method එකක්, right? It is also the similar method or similar kind of a network to Wi-Fi, but Wi-Fi is short range and Wi-Fi data rates are less. But in WiMAX, higher data speeds are there, right? It supports higher speeds and greater distances. It can, the ranges can go up to miles. හරිද? එහෙම නැත්නම් සතපුම් ගණන් දුකට සතපුම් ගණන් දිගට wireless network එක extend කරන්න පුළුවන් අපිට WiMAX network එකක් සතපුම් ගණන් දිග වෙන්න පුළුවන්. Now, unlike in Wi-Fi is only up to a few meters or 100 meters or only a few meters, right? And for greater number of users, the number of users that can be connected to a WiMAX network is much higher, right? WiMAX has the ability to provide service even in areas that are difficult for wireless infrastructure. Now, for example, WiMAX is also used to provide broadband access for areas which we cannot use wired devices, wired networks. එතකොට copper network එකක් යවන්න බැරි. එහෙම නැත්නම් fiber network එකක් යවන්න බැරි. Areas වලට අපි broadband access දෙනවා මේ wireless WiMAX network එකේ, right? WiMAX technology එකෙන් අපිට පුළුවන් broadband access then wirelessly, okay, to those areas which we cannot lay a fiber network or a copper network infrastructure. හරිද? සමහරට hilly areas තියෙනවා, rural areas තියෙනවා, දුෂ්කර පැති තියෙනවා. හරිද? ඒ වගේ පැති වලට wireless solution එකක් තමයි දෙන්න පුළුවන්, right? To overcome the physical limitations of traditional wired infrastructure. To implement a wired network, we need to have a lot of infrastructure. To implement a wired network, we need to install a lot of infrastructure. Different cabinets, the cabinets install karanna ඕනේ, different access nodes should be installed in between. But certain areas, it is not that easy. සමහර පැති තියෙනවා එච්චර ලේසි නෑ වගේ දේවල් implement කරන්න, right? So therefore, WiMAX is a good solution. Why do we need broadband access? It will fill the gap between high data rate wireless LAN and very mobile cellular network. So broadband access means it provides higher data rates, okay? Then wireless alternative to cable and DSL for last mile broadband access, right? So WiMAX is the wireless alternative to, actually now it should come like this. Broadband wireless access, which is WiMAX. Broadband wireless access. Well, importance economic and broadband wireless access means WiMAX, okay? Now, wireless alternative to cable and DSL. Ithura cables are DSL යවන්න බැරි වෙලාවල් වලට WiMAX පාවිච්චි කරන්න පුළුවන්, right? For in developing countries and in rural areas. Then provide high-speed mobile data and telecommunication services through this technology. Okay, it is only for the last mile network to provide broadband access in areas where we can't use fiber optic cables or coaxial cables. We can use WiMAX to provide broadband access to the users. So it is used in the last mile network of a telephone network. Overall network core network integrated and aggregation network පාවිච්චි කරන්නේ last mile network by user ළඟම කොටසේ network කොටසේ. So what is the network segment which is closest to the user? Last mile network, which connects user to the central office or telephone exchange, closest telephone exchange. Okay, that network, last mile network. So WiMAX is expected to offer initially up to 40 Mbps data rates. for wireless channels for both fixed and portable applications. Fixed and portable applications means for fixed user devices or portable user devices. WiMAX can support voice and video as well as internet data. WiMAX developed to provide wireless broadband access. So this is the word. It will provide wireless broadband access to buildings, either in competition to existing wired networks or alone currently unserved rural or thinly populated areas. So it is not just used in rural areas. Difficult areas are it is the wireless solution to wired broadband. Wired broadband is a wireless solution. So it can be used in buildings also. WiMAX, which is an IP-based wireless broadband technology, can be integrated to both wide area 3G mobile and wireless and wireline networks, allowing it to become part of a seamless anytime, anywhere broadband access solution. So WiMAX is compatible with the mobile network, with the wireless network, with the wired network, right? Wired broadband network එකත් compatible, mobile network එකත් එහෙම නැත්නම් 3G mobile network එකත් compatible. So it is a good technology. It provides anytime, anywhere broadband access. Okay, WiMAX provides anytime, anywhere broadband access because it is compatible with all these other network technologies. Okay, right. So these are the data rates that are used in WiMAX. WiMAX වල පාවිච්චි වෙන data rates තියෙනවා. WiMAX වල පාවිච්චි වෙන data rates තමයි. Now these are different WiMAX standards. The main standard is 802.16. Okay, so these are the data rates up to 75 Mbps, up to 30 Mbps, and these are the coverage ranges up to 10 miles, up to 3 miles. Balanda, always WiMAX is a wireless broadband access technology, but it can provide data rates which are higher, and communication range is also very high. හරිද? සැතපුම් 10ක් දක්වා wireless access දෙන්න පුළුවන්, right? Who joined now? Lakshita Malaka, what's your registration number? Got disconnected. එයාද අබේසිංහ කියලා කියන්නේ? අපේ phone. Okay. NLM update only. Okay. Right, so these are the data rates. Right? So uses of my WiMAX, it provides portable mobile broadband connectivity across cities, countries through various devices. Portable mobile broadband connectivity means the mobility is high, right? Providing a wireless alternative to cable and digital subscriber lines for last mile network. So it is a wireless alternative to wired network, wired last mile network, including DSL connections, right? It provides data telecommunications, voice over IP, then IPTV services or triple play. What is triple play? IPTV, in broadband internet, and voice, right? So all these three are called triple play. So those kinds of services can be accessed through WiMAX broadband network, right? Then Zigbee. Zigbee is the other wireless network technology, right? Anik technology එක තමයි Zigbee කියන්නේ. So what is Zigbee? Any questions from YMAX? Doubts තියනවද? Zigbee ගත්තොත් Zigbee is a sensor-based network, right? So wireless sensor-based network. Now, sensor network එකක් ගත්තොත් it is a different kind of network, right? So it can operate for years without any manual intervention. So it is used for collection of data. Data collect කරන්න පාවිච්චි කරනවා sensor network එක, wireless sensor network. So Zigbee is a kind of a wireless sensor network, right? So it has an extremely long battery life. Years අවුරුදු ගණන් පාවිච්චි කරන්න පුළුවන් battery life එකක් තියෙනවා. It is used to collect data mainly. Data collect කරන sensors වලින් කරන්නේ data collect කරනවා, right? So data on different, let's say the climatic changes and different installed in different areas. It will form a certain network, right? So its battery life is very long and infrastructure cost is less because they do not fail easily. And the complexity is less and size is small. Device size is small. Sensors are small in size. They do not fail easily, right? Their battery life is very long. It can survive for years. Right? The sensor network is hadala. දවසින් දෙකෙන් battery බහිනව නම් බෑනේ. Sometimes sensors are installed in areas where there are no power available. Power නැති. හරිද? Power outlets නැති areas වල sensors පාවිච්චි කරනවා. හරිද? ඒතකොට ඒවයි battery life එක ගොඩාක් වැඩි වෙන්න ඕනේ. Size එක අඩු වෙන්න ඕනේ. Power consumption එක efficient වෙන්න ඕනේ. Right? So designing a sensor network or sensor node is not that easy. Wireless sensor node එකක් define කරන එක එච්චර lazy නෑ, right? So it is not easy because you have to optimize everything. You have to minimize the power consumption. You have to maximize the battery life. You have to design, wireless sensor node is something which collects data. It has a processing unit inside, right? So it will collect data about different, let's say, for example, a traffic control system, right? So sensors are installed, right? So they are, the sensor will, detect the different things in the road, right? Different things that are happening. But if you want to store images in the sensor node, it is not going to be easy, right? So to store images, you have to use huge memories, right? So when you increase the internal memories, then the power consumption can be high. So those kinds of, there are a lot of things that you need to consider when you design a wireless sensor node, right? So a sensor node can be installed, can be put in different places to collect data for further processing. හරිද? data collect කරන්න තමයි ගොඩක් වෙලාවට sensors පාවිච්චි කරන්නේ. sense කරනවා කියන්නේ මොකක්ද? පිටින් මොනවා හරි දෙයක වෙනස් වීම capture කරනවා, right? So sensors are installed not only in places that are accessible. සාමාන්‍ය අපිට යන්න පුළුවන් තැන්වල හැමතිස්සෙම human intervention එකක් දෙන්න ඕනේ නැති තැන්වල තමයි මිනිස්සු මිනිහෙක් ගිහලා හිටවලා data collect කරන්න අවශ්‍ය නැහැ. හරිද? The traffic monitoring system, the person can stand on by the side of the highway and person can't calculate the speed of a vehicle, right? Vehicle speed calculate කරන්න මිනිස්සෙකුට බෑනේ. So sensor will do that. Sensor will collect data about the day's traffic, right, that is passing through the highway, different speeds. It will take the averages, it will collect the data, it will send to the other nodes to analyze the data, right? And then low device data rate and quality of service. Standardized protocols allow multiple vendors to interoperate. So this wireless sensor network, or we also call it as WSN, is a quite different technology. So you need to know, in order to implement a sensor node, you need to know a lot of things about electronics, right? So if you want to implement a sensor node, right? Design a sensor node. So you have to first consider the purpose of your data collection. Why do you, what is the purpose of your data collection, right? And the other thing is what kinds of internal electronics that you need to consider, because that everything has to be optimized in a sensor node, right? Power consumption should be very less, okay? Battery life should be very high. Data processing is limited, right? You cannot process data as much as you want. Your storage is limited. So sensor node is something which is very designed for very difficult situations, right? Difficult environments. So the sensor network, which is created by joining these nodes, which communicate with each other, is the Zigbee, right? So this is the wireless standard for that, IEEE 802.15.4. Remember, 15.4 covers the physical layer and the MAC layer of low rate wireless personal area network. Okay. The Zigbee is an emerging standard that is based on 802.15.4 and adds network construction. So there are a lot of network topologies, star, peer-to-peer mesh, cluster tree networks, right? A lot of topologies are there. Okay. Then a new standard which became publicly available in June. It is a rather new standard, right? Based on 802.15.4. Then now the Zigbee is mostly used for application layer services, right? Application layer services. Zigbee is mostly used for application layer services, right? So you will see now it is also IoT based or Internet of Things based technology, right? Zigbee is a IoT based technology. So the wireless sensor nodes sensor network IoT based, right? Internet of Things based. And this has many applications based on the connection or the interconnection between different things. Okay, Zigbee. So IoT also makes use of Zigbee. So if you are planning to study about IoT, you should know about Zigbee as well. Why Zigbee? It has low cost, right? It can be used globally, reliable, easy to deploy. A large number of nodes can be interconnected together. The battery life is very high. It is secure. So these kinds of things, right? Then this is where the Zigbee falls. Zigbee the method. Data rate is very less in Zigbee, right? So compared to Bluetooth, WiMAX, and Wi-Fi, and those kinds of technologies that we discussed, Zigbee data rate is very less, right? And it is in this range. It also has a lesser communication range, right? Now, Zigbee standard uniquely fills a gap for low data rate applications. Low data rate applications in a gap for the Zigbee standard, right? So if you are interested in IoT and if you are interested in with wireless sensor nodes, then of course you definitely need to study about Zigbee. Okay, it's a must. And these are the different applications of Zigbee. You can see now home automation systems based on Internet of Things, IoT. That is also a Zigbee standard kind of architecture, network architecture, right? So lighting control, access control, right? Patient monitoring systems in healthcare, in telecom services, services like m-commerce through information services, object interaction, Internet of Things, right? So every of these applications are based on sensors. IoT and sensor-based network, right? So Zigbee is basically a sensor-based network, and the latest, one of the latest technologies, because Zigbee is introduced in 2005 only, so it is a very current ongoing technology, right? Network standard. Okay, so if you are interested, you can search for more about Zigbee. Now these are the device types in a certain Zigbee network. Zigbee network එක device types තියෙනවා. These are important. There is a Zigbee coordinator, Zigbee router, and a Zigbee end device, right? So what is done by the Zigbee coordinator? It initiates the network formation. It is the main function performed by the Zigbee coordinator. So it will start the network formation. It will start forming the network, right? Zigbee router, it does routing. Zigbee end device, it does not allow routing, right? It enables very low-cost solution. So here you can see, this is in this topology. I told you there can be different topologies: mesh topology, star topology, cluster. So this is the coordinator. This is the one who has started the network, or who has initiated the network, Zigbee coordinator. Then these are the Zigbee routers. So these routers will route information. End devices means they do not route, right? So they do not pass the packets to other devices. They only communicate with the ones that they are connected to. That's all. They are not passing it to the other devices. So the last end nodes are called the Zigbee end devices. Antima end nodes, end devices, right? So all these play main roles in a Zigbee network architecture. Then that's all for the other different technologies, different wireless technologies. Wireless technologies වල ඔය ටික තමයි කරන්න තිබුණේ. Right? So I discussed about WiMAX, Zigbee, Wi-Fi, Bluetooth, right? So just remember the specifics or things which are specific to different standards. And also remember the IEEE standard for each network technology, wireless technology, right? So that's all that I have planned to do today, and hopefully you have understood. I'll upload the slides also. This is the last lecture. If you have any questions, any doubts from the previous lectures, you can contact me. So I have given you my mobile number. If you don't have it, you can ask from someone, right? And you have my mobile number, and I'm in WhatsApp. You can contact me through WhatsApp. If you have any issues, if you do not understand anything, you can contact me, right? And also, if you need any extra lectures, right, to revise the things that we did already, maybe in the near upcoming weeks or right before the exams, you can contact me, okay? If you do not have anything, if you have things that you do not understand or any specific lectures that you want me to redo, මට කරන්න අවශ්‍යයි ඔයගොල්ලන්ට ආයි explanations අවශ්‍ය කොටස් තියෙනවා නම් ඒවත් එකතු කරගෙන we can do another lecture, but our syllabus is over, right? So it is completed, okay? Eka complete, syllabus eka complete. You can ask me anything, any doubts that you have. You can personally contact me, or otherwise you can ask me to conduct a separate lecture for that if you have any questions, okay? I'll definitely do a revision lecture, one or two. One lecture for maybe a paper discussion, and the other one, I mean, if I do a paper discussion, then it will cover everything, okay? Still, I will do a separate revision lecture. Revision lecture because we need to do a few more decibel calculations from different, we did some calculations on free space propagation model. Then we also did some calculations on what is that? What is? Oh, frequency reuse concept, cellular network architecture. So we'll have to practice more questions on that. And there were a few more, questions in the exam paper also. You can practice. You can do. When I do the revision lecture, you should come with your answers. Okay, you have to solve the questions and find answers. You can refer to the slides, find answers, and you have to write answers and come to the lecture. Okay, then we can discuss, right? Okay, so any other doubts you need to know? Many of you have submitted the assignment. I think all of you have submitted the assignment. I'll give you the marks. You also did the presentation, right? So presentation, many of you did really well, all of you actually. Your assignment also, I think you have done it properly. So 15 have applied to this one, and then 2 in English, right? So if you have any questions, everyone has submitted the assignment, right? Okay. So I'll mark the assignment and give you the marks in upcoming weeks. Okay, මට දවසක් නම් promise වෙන්න බෑ කවදද marks දෙන්නේ කියලා. හැබැයි many of you, every one of you have scored well in your presentations, right? So don't worry about assignment marks. Prepare for the exams. I don't know the dates, but officially my part is done. If you have any questions regarding anything that you need clarifications, you can contact me directly on WhatsApp or any other means, or you can email me, whatever you prefer. Okay? Right. අනිත් එක ඔයගලන්ට තව extra lectures කරන්න ඕනේ නම් discuss කරලා එකක් මට කියන්න මම කරන්න weekend එක වගේ. හරිද? හරි. So, okay. Shall we wind up the lecture from here then?